All right, here we go. And I'm going to share my screen. All right. So, hi, everybody. This is Coding Challenges with Pam. And it's going to be, I'm just getting things set up here, you know, somewhat informal. What I really want to do is, start a conversation with you guys about techniques and approaches to solve problems. Um, because kind of where I come from, and it's probably why Mike and I make a good combination here. So I'm not always the person that initially comes up with the big old best solution, because I have actually taught primarily uh, sort of beginning, intermediate coding classes. I really like teaching those classes. I really like kind of laying foundation for how you do problem solving and how you approach doing things. And so in my classes, that's not always the main focus, but we're going to be talking about that as well in here. So welcome everybody. Um, so I guess we'll just kind of jump right into what we're doing, because I want to talk a little bit about the solution, and I want to talk about some ways to what you guys came up with. And I actually have another problem that I kind of mentioned that you probably haven't finished, but I want to talk about it a little bit to maybe give you another problem to start thinking about, as well as the new one that we put out. So again, the only way you get good at solving problems is to solve problems. I know in some of the interviews that I had with a few of you guys, some people asked me that. And I wish there was some magic fairy dust that I could sprinkle to make it really easy. But honestly, it's the struggle and the practice that makes you get better. Matter of fact, quick little story as people are coming in about struggling through problems, because in some of the presentations for the projects, I know I heard people say something like, I spent half a day trying to figure out how to do such and such. And I know that may have seemed like a long time to you, but honestly, that's not necessarily a long time to spend time solving a problem. And the little story that I like to tell my students is the story of the butterfly and the struggle with the butterfly. So a kid sees a cocoon that's going to be a butterfly, and it's starting to try to come out of the cocoon, right? So the kid decides to help the butterfly because it seems like it's struggling. So it kind of helps and opens it up to make it easier to come out. Well, it turns out that's a problem, because that butterfly was never able to fly, because it turns out the process of struggling to get out is how the wings get strengthened. And so, a lot of times I know struggling through something doesn't always feel good at the beginning, but I need you guys to know that, especially if you're going to be in this tech world, that's just the way things work. And sometimes you may spend a couple of days thinking on how to do something before you actually get it done. Okay. So with that in mind, we started with a somewhat easy problem here, I think, but I want to talk through it a little bit. So this isogram challenge. Um, First of all, I just kind of want to know, can I assume, did everybody here actually get a solution? Can you guys maybe use a little hands thing to tell me if you got a solution to this? All right, so I see a few people there. So, and I might kind of call on people. I don't know. We'll see how this goes. Because again, I don't want to just talk. I want to kind of initiate a conversation about how to approach these things. So maybe I won't call, but maybe I'll ask for a volunteer. Does anybody want to volunteer and talk a little bit about how you solved it, or about the approach that you took? Maybe not the code yet, but kind of the approach that you took to solving this problem. I got any brave people that might want to do that? All right, so I'll tell you what, I'll help you out a little bit here. So let's talk about it a little bit.
Actually, I think Guilo says he wants to volunteer.
Oh, okay, cool. I didn't
Yeah.
see that. Yes,
In the
please.
chat.
Oh, I see. I need to get my chat up. There we go. There we go. Okay. Is it Guilio? Guilio? Yes. Let me hear you. Can you turn your microphone on? There you go.
I don't hear anything.
Yeah, I don't either. It looks like your mic is on. Are you? Oh,
Oh wait.
oh,
Oh, he's having issues. I think he had problems with his mic when he was doing presentations too. Like,
I remember that.
yeah.
Ah, okay. Anybody else? Let's see. I see Dinah says.
Sorry.
Okay, so I see some people that haven't. So, all right, let's talk through it then. That might be a good thing to do, to talk through it. Who's that?
Wait, I think I got it figured out.
Yeah, I hear you.
All right.
Perfect.
So again, that code, I want to just kind of talk through how you approached it. Okay.
Okay, sure. So when I approach a problem, I like to look at it top down and just write down what the problem is. So in this case, we wanted to see, although, yeah, let me, it's been a few days, let me see exactly. No repeating letters, here we go. And then our examples show us that we want to ignore letter case. So the first thing I did is just write down what the necessities were, such as figuring out if it has the same letters or if it's lowercase. First thing I did was trying to remind myself how to turn everything to lowercase. So I would have to have everything working, all in lowercase, so I wouldn't have to worry about that later. And then I tried to remember ways to figure out if a letter has been used already. And there's two ways I thought of. One was using a loop on lists, and the other one was using a tuple, I believe it's called. I couldn't remember how to use tuple, so I just decided to use a loop on lists.
Okay, so good. That's a good kind of starting point here. Let me bring up a couple of things from what you said. So you talked about this ignore the letter case. Now, there's two ways to approach something like this. Sometimes the way I like to do, you said, so I'm going to deal with that first. And that's certainly a good approach. For me, sometimes the way I like to approach a problem is you have a big problem to solve. I think of it as kind of layers of an onion. I want to peel away certain things so I can get down to the core of what I need to do. And so one strategy is to actually simplify or remove features, because the uppercase, lowercase thing might be something that is kind of obvious to you, but to me, it's something that I can kind of put aside and say, well, I'm going to try to solve the problem without dealing with that. But what that means is when I test it, I have to know that, for example, this third case here, this is not a test case that I'm going to run to start. So either way is a good approach, that you have to decide whether you're going to deal with that up front or whether you're going to maybe put it to the side. So I'm going to actually put it to the side to start. Now, the second thing that you mentioned is very good, is that you have to look at an example. So when you're given examples like this, then you need to start and kind of work it out on paper, right? I'm trying to make this a little bigger here. So here's an example here. Now, this is a really long one, but we say, why is this true? What am I doing here? So I have to look at each letter and somehow decide, have I seen this letter before, right? So let's kind of write some things down as I do this. So I need to look at each letter and determine, have I seen it before, right? Well, I wrote down two separate things there that have to actually be dealt with. I can't determine if I've seen it before until I'm sure that I know how to look at each letter, right? So I think what I'm going to do, I'm going to bring up a VS Code window over here, and we're going to do a little code as we go along. So what I did, this is actually kind of my little playground for doing, you see, I've got a lot of JavaScript files over here because I'm just testing a lot of different things. So I just have a simple HTML page that has, as a matter of fact, I'm going to change this to code challenges. And this is going to be my code challenges. And then I can use whichever JavaScript file I want to when I run this, right? So I'm going to go over here to this isogram.js. Actually, I'm going to start a new one. That's what I want to do, because I want to show you guys as we go through it. So I'm going to start a new one, and I'm going to save it as isogram2.js. Because I want to kind of show you guys, for those of you that haven't done it, I want to sort of walk you through the process that I think, and then going forward, hopefully that'll give you a good foundation. Something that I always do that I'm not sure was mentioned in your teaching. Does anybody know why I might use this, what this use strict is? And by the way, so I'm going to be doing this in JavaScript. I know some of you guys may be doing Python and some other language, but I'm going to be doing this in JavaScript. Does anybody know what this is and why I'm using it? I'm not sure if it's something that you guys have ever been exposed to.
So I think I've seen that in Perl, and I think it forces you to use proper, I can't think of the word, proper structure when you're coding. Like sometimes if you miss a comma or something, the interpreter will assume what you mean, but using strict means that everything has to be correct and intentional.
Yeah, now I'm not sure, honestly, I don't think it deals with semicolons because, in JavaScript, semicolons are actually optional. But what it really forces you to do is to make sure that all your variables are declared before you use them. Because, JavaScript, honestly, I call it kind of the laid back language because it'll let you get away with some things that other more strictly typed languages don't. So this just makes sure, and it'll help you sometimes if you have typos in variable names. If you have using strict on, then it'll complain to you if you have a typo because it'll be something that's not declared. So I always start with that. All right, so the first thing that we have and the other thing, guys, that to me is very important is to write comments, to talk to yourself about what is it that I'm trying to do. So we are writing a function, and I'm going to go over here and bring up what I have. Hold on, give me a second. I have too many windows going on here. Okay, let me get it from over here. So this is the function that I want to write. I want to write a function called, here we go, is isogram, and it is going to take a string as a parameter. And I want to tell myself, what is this function supposed to do? So I need to check all the characters in str. That's the name of my input, right? Return true if no duplicates. Okay, so let's focus on the first part of this. I actually need to walk through each letter that is in this string. So I can't do anything else until I figure out how to do that, right? Another thing for me that's really important is to take a problem and break it down and sort of understand the dependencies and not necessarily be in a rush, but check step by step to see if things are working, okay? So anybody tell me an idea of what I need to do if I want to just print all the characters that are in a string? How can I reference all the characters in a string? What kind of structure do I need to use to do that?
What about console.log with the argument of string str?
Okay, so we are going to do that because that's one little part of it, but that's not going to get me quite what I want. But I want to do this because I want to show you. I'm just having a problem on my other window over here. Okay, here we go. So, but that's also a good idea to do, is to just, I use console.log all the time. And when I do it, I do something like this. So I know what it is that I'm printing out. So this is my function, and I'm going to need to test my function. So I'm gonna call, right now I don't have it returning anything. So I'm just going to call Isogram, and let's pass it, I don't know, I'm going to pass it a word like happy. Okay. And I just want to see what it's going to do. So I'm going to save, and I have a window over here. I have live server going on. And so I should have this window over here. I think I got to start it again because I started a new. So I'm going to go to index. I'm going to, I'm having problems with my windows here. Here we go. Where did my file go? Index. Open with live server. All right. So here is my window over here. And I need to inspect this page so that I can see my console. And you know what I don't think I did? So let me go, let's see, I'm calling isogram.js. Here's isogram. Oh, that's the wrong one.
Isogram 2.
Yeah, so I'll be calling isogram 2. You see, so this is why you go slow and you check. All right, so we do this. All right, so we know, so I know a couple things. I know I'm running the right program, right? And I know I'm connected. So that gives me the entire string. But in order to figure out if I have duplicate letters, I'm going to have to be able to reference every individual letter, right? So a string, so Amy is telling me make an array of characters in string. But look, here's the thing. A string is already an array of characters. So I actually don't have to do anything special to make it an array. So if it's an array, anytime that I want to reference or walk through everything in an array, what should immediately come to mind?
A for loop.
There you go.
For loop.
That's right. So I'm going to say for let I equal 0, I less than, how far do I go? How do I know where the end of this is?
String.length.
That's right. I plus plus.
I have a question, just
Sure.
because I'm Python and that's JavaScript. Is a string not iterable in JavaScript?
It is.
Yeah,
You can use an iterator in JavaScript to do the strings. Yeah.
yeah, yeah.
Okay.
So again,
Yeah, just the approach was different in Python, so I was wondering.
yeah. There's a lot of ways to do things. That's why Mike's going to be here to keep me honest, because I know a little bit of Python, but Python is not an instinctive language for me right now. And Python allows you to do some things, but yeah, that is true.
Also,
All right.
iterators are relatively new in JavaScript too. So like they're not necessarily, they're supported in all browsers nowadays. But if you find older code, you won't necessarily see use of iterators as much. But yeah, you need the for of statement actually to iterate over the values.
Yeah.
But, yeah.
And I'm going to show that way as well. I'm going to show both ways. So here, if I want to reference this console.log, I can print out str. Actually, I usually do it the other way. Let me double check. I think that's how we reference it. Or do I have to do char at?
Oh, that's right. No, that works.
This is because I have too many languages in my head. So, and this is also why I test. So let me where's my save? I'm having problems here with my save all. Here we go. And so look at what I got. Here's my console. So I've got my HA, 2 Ps, Y, right? So I know that that worked, okay? So again, you can't, you got to make sure don't go too many steps forward without sort of verifying what's going on. Now, just to show you, there are 2 ways to do a loop to iterate the string. So I've got this one. I'll show the other one as well, because I think I'm going to actually use the other one as well. So the other one is I can set up a for loop where I can say for let C of string. And C is going to walk through and give me every single letter. It's going to walk through every position of the string and give me every single letter. So I'm going to now do console.log C. And we're going to get the same thing. So I'm going to save this. And lost my window. Here it is. And I've got the same thing, right? So now I know that I can reference every single individual character that is in the array. And I think I'm going to keep the second one as the one that I want to use, the one that actually replaces C. So do you guys understand? And as I'm doing this, if there's any questions about, why we're doing that or how that works, please make sure and speak up, okay? So now, and I don't need this console log anymore. I always have lots of console logs sitting around after I finish. So I have this letter. So this is what I like to tell my students. I have to talk to myself and say, what is it that I need to do? So I need to somehow, I need to determine if C is repeated in the string. Because here's another thing to keep in mind when I'm doing something like this, a method that's trying to figure something out and trying to return true or false. So for example, if I'm going through this string happy, should I need to look at every single letter in the string before I know what the answer is? Because in this particular case, so let's kind of walk through it. This is a good thing to do. So I look at my H. Again, we haven't figured out how we're going to do this in code, but let me talk myself through what I want to do. So I have an H. Is there more than one H in this string? No. So far it's still a candidate for being an isogram, right? I have an A. Is there more than one A in here? No. So it's still a candidate. I have a P. Is there more than one P? At this point, there's not, right? So it's still a candidate. Now I find another P. So at this point, I know that it's not. Do I need to look at the last letter? No, I don't, right? So a lot of times in a situation like this, you want to think about coding, what is the condition where I can basically jump ship and say, I'm done. So I'm done if I find a repeat. All right, so we'll keep that in mind as we're doing this. So now, how can I figure out if C is repeated in the string? Now, I want to get to the fancy ways of doing it, but I want to start with just maybe the brute force approach to doing this. So we know right now that we know how to walk through every letter that is in the string. So if I wanted to count, for example, if I have this string happy and I wanted to count how many P's are in happy, what would I do? I'd have to walk through each letter and say, are you a P? Are you a P? Are you a P? Right? And when I find one, I count it. And then are you a P? I find another one, I count it, right? So we can actually do this by walking through the string again. Now, again, this is obviously not going to be the most efficient solution, but this is a solution. And sometimes the reason why I want to bring this up is I think sometimes people get a little stuck trying to figure out what's the best way to do this, when I think sometimes you just have to come up with a way to do it. And once you do that, then you refactor and you can figure out ways to make that solution more efficient. Okay. So go ahead. Is that a question? All right. So I'm gonna write a comment to myself here. I'm gonna say, I need to count how many times C is in this string. So notice I'm inside this for loop, but I'm about to make another for loop inside of it because I'm going to walk through it again, right? So that means I need a counter. Yeah, this will be posted afterwards. So I'm going to say, I'll call it count equals 0. And I'm going to walk through the string again, because now I want to walk through the whole string looking for C in that string, right? So I'll do again, walk through and count. So 4, and I'll have to use a different variable in here. So I'm going to call it LTR for letter of string. Is this the letter C? So that means I need to test, right? So I'll have to write an if statement. So I'll say if letter is equal to, remember you have to do double equals, C, then I want to count it. Now, let's do a test to see. Oh, good. Thank you, Mike, for doing what you're doing there. Now, why is it telling me? I think we're fine. All right, so where is that?
I think it wants a semicolon.
Thank you. There you go. That's a colon. I need a semicolon. Boy, I am doing serious multitasking with this thing here. All right, so let's check. Let's do console.log, and I'm going to print out the appears count times, right? Because I'm testing to see if this works so far. So I'll save this. I'll go over here. We're running it. So look at what we've done. I've looked at the letter H. I walked through the string. H appears 1 time. A appears 1 time. P appears 2 times. And again, we're checking it each time. P appears 2 times. Y appears 1 time. So it looks like I figured out how to count, right? So now that I know this, then once I get out of this loop, return false if count is more than 1, right? So if I've only found this letter 1 time in the string, then there's still a chance. But if this count for this particular letter is more than 1, then I know we can exit, right? So how would I write this if statement? If, what am I testing?
If count is greater than 1?
Yep, that's it. If count is greater than 1, and if that's true, what can I do? I just return, I'm out, I'm done. Return false. I don't even have to check anymore. So in walking through this, if I'm doing the word happy, I'll check H, there's only 1 H. I'll check A, there's only 1 A. When I check P and find that there's 2 Ps, it should return, right? Because I'm done. At that point, I can't do anything more. Now, so here's this entire for loop here. So this is the end of my outer loop. So how do I know, when do I return true? So I figured out, I think, we're going to test it in a second, but I need my return true in here. When can I determine, I know when I can determine that it's not an isogram. When in this code will I be able to conclude that it is?
When C is equal to 1.
Well,
How
that,
about 0?
well, okay, so
Or
let's,
less
When you
than
made
0.
it through the whole string and you didn't return false, then that means there's nothing else. So it has to be.
there you go. Who is that? Daryl, I think I'm hearing. So look, so here's where a lot of times you need to kind of walk through and let me think. Let me do some paperwork and let me think about how to do this, right? So in this case, we already figured out this is going to be wrong, right? So wait, I need a case where I'm not going to have, so let's do a different word. Let's do if my word is red. Okay, so I'll go through the R and I'll check how many R's are there, and it'll come back and tell me that there's 1 R. But do I know that it's an isogram yet? No. So this is a good little thing to be aware of because I have an if statement here, but I'm not going to have an else here because if count is greater than 1, I know it's not an isogram. But if it's 1, can I conclude that I'm done? So right here, once I find a 1, do I know that I'm done? No, right? I have more letters to check. So I have to check the E. How many E's are there? There's 1. Can I conclude it's an isogram? No. So I have to check the D. How many D's are there? There's just 1, right? So I can't conclude that it is an isogram until I have looked at every letter in the string. So that means that is here. Once I finish this entire loop, if I get here, it must be an isogram. And notice that's because when you have a return statement, return means you exit. So at that point, you will not do any more looping in there, right? So if we walk through the entire string and I get here, then I would return true. So let's do a little test here. So to test this, I want to look at what is being returned by this. So if I run this with my happy, so here's what happened, and I can kind of see what happened. We checked the H, we checked the A, we checked the P, and once we saw it was 2 times, we returned false. It's not an isogram, right? So let's check it with something that is an isogram. So let's check it with red. So now, here's my thing. So we checked the R, we checked the E, we checked the D. So we have to check them all. And once we've checked them all, then I can say that it's true, right? Now I'm not dealing with the upper and lower case. So now I might want to think about this. So that would mean that I would need to change this letter. I could do it in this if statement here, right? I could see if letter dot, so how do we change a letter to lowercase? So one of the reasons why I save that sometimes for later is because I have too many languages in my head and the syntax of how to do upper and lowercase is different in every single language. But in JavaScript, it's is lowercase. So I can do either one. That is, not is lowercase, sorry, to lowercase. To lowercase. To lowercase. So we can test this by, let me do my hello, and let's do H-E or happy, H-A-P-P-Y. Let's do something like that. And this should return false, even though I have upper and lowercase letters, right? And here's my window over here, and it gave me back false. So, I knew I had that other little feature I needed to add in. So what I'm doing here is just in the if statement, when I'm checking, I can check the lowercase version, or I could check the uppercase version. It doesn't matter. But what's important is if that's a feature that I'm checking, then I need to have a test case to check what goes on when I do that, right? So let me do a quick little pause just to see, how are you guys with this algorithm. Is anybody have any questions on how this works, why this works, what's going on with this? But why is it not very efficient? What's the issue? Or what's the complexity of this? So I'm looking through each character of the string twice, right? Because I have a loop inside of a loop. So this would be big O of n squared, because for each letter, I'm walking through the string again to look at each letter. So from that standpoint, it's not a very efficient way of doing it, right? Okay, you guys got to talk back to me.
Yes. I know it.
Okay. Is it all right? So should we go on? So let's think about a way to make it more efficient. So you may have any ideas about how we can do this and only look at each letter one time? Anybody have a better way to approach this?
I do, I think.
Go ahead.
Okay, so the way I did it to only look through it once is that inside of the one loop, I check, well, actually, before the loop, I have an array called letter bank,
Mm-hmm.
which is empty. It's an empty array.
Mm-hmm.
And inside of the loop, I check if I do the same loop for letter and string. I check if the letter is inside the letter bank,
Mm-hmm.
and if it's not, it puts it in there. And if it's already in there, then it returns false.
Yeah, so let's kind of walk through that idea here, because again, I think you have to walk through these ideas on paper to make them make sense. So what, and it's Julio, right? Am I saying it right? Yeah. So what he's saying is, let's keep a list of the letters that I've seen so far. So it's going to be another array, or we're actually going to talk about something else that it could be, but we'll start off with it as just an array. So if I think about, this is a list of the letters that I have seen so far. And so it's going to start off as an empty array. So I look at the first letter and I say, have I seen an H yet? We'll have to figure out how to code that, but that's the concept. Have I seen an H yet? No. So let's add H into the list of letters that I have seen, right? When we keep looking, let's walk through E. Have I seen an E yet? No. So I need to add E to the list of letters that I've seen. Have I seen an L yet? No. So I'll add L to the list of letters that I've seen. When I go this L, have I seen an L yet? Yes. So I'm done. I can exit, right? So this now means that I'm only walking through one time. So
That's still an O of n squared solution, I believe.
is it? Now, this is where you have to keep me honest.
Okay.
Like,
So if
yeah.
you think about it, like every time you search for a letter, you're going through the list of all the letters you've seen so far. So before you had the problem of going through all the letters of the whole string that were beyond the letter you're looking for, but now, or that are in the string. And then now you have the problem of repeatedly looking. In order to tell whether you've seen a letter before, you have to kind of walk through the letter bank. So the letter bank is going to have a cost of walking through all of the things that are previously in the letter bank, every letter.
If I use includes, then
no, then it just puts it into the JavaScript compiler, which is then doing this, the walking through that. So you have to use a different data structure. This is where the data structures and algorithms comes in. Like, yep. You need a different data structure, one where you can look up something to see if it's a member of, well, I'll call it like a set. It's like you need to say, is the letter H in this set? And you need a data structure that is going to be fast for that. And there are a couple of choices in JavaScript.
Yeah. And so set is the one that we're going to use, right? One of the ones that
Yeah, set is, it's kind of newer to JavaScript, the set data structure, but yeah, you could use the set data structure and that's very fast. Or you could use a regular JavaScript dictionary, an object. You can also use it to index by the letter and look up like true or false, or look up whether you could just put it in the dictionary. And if it's in that object as a property, you know it exists and it's fast.
Yeah. So let's do a set.
Sorry, I have a question. Objects are faster than arrays?
Objects are O of 1. So constant time, you can add a property to an object and you can test, and then you can extract the value of where you use a property as a key in an object. So JavaScript objects are basically hash tables, and you use a hash function to internally they're doing a very efficient lookup of the properties of JavaScript objects. They don't iterate over all the properties in order to extract the value. Does that make sense?
Yes, that's cool.
Yeah.
So we're going to create, and look, when you come across something like this and you say set, what's a set? All right. My favorite place that I go to look things up, at least a quick little, for syntax and that sort of thing, is W3 Schools. So JavaScript set. Right. So I'm going to show you guys something cool about a set. So a set, the thing that's unique about a set is each value can only occur once in the set. Right. So let me actually show you something really quick about how that works. So if I'm going to create a set, so I'm going to say, let nums equals new set. Do I just put an array straight in there? No, I'm trying to remember. All right. So, and then to add things to this set, there's an add method. So I'm going to show you something. If I go nums.add, I'll add a 2. Nums.add 5. If I add 2 again, I'm only going to have 1, 2. A set is not going to repeat anything that is in there. So I'm going to print out nums is.
Actually, if you use Pam, if you use a comma instead of a plus, I think the dev tools will give you a better display that you can interactively click on the value. Yeah.
Let's see here. And guys, you know what I want you to understand? This is why, honestly, 2 programmers are always better than 1, because nobody ever knows everything. And so thank you, Mike. That's a cool little thing that I actually didn't. So you see that even though I added 2 in here twice, I only get 1, 2 in there. So this is it's a more efficient data structure. And if I look over here at the things that are available, somebody else coming in. So this is how I make a set. I can add things to the set, and I have a method called has that returns true if a value is in that set, right? So that means what I can do over here is in my function, I'm going to create a set of all the letters so far. So I'm going to say so letter bank is a good name for it, equals new set, right? So now I still need to check all the letters in the string. I'm going to walk through. So I'm going to have 4.
You made it plural, by the way. Letter banks.
Thank you. So I have that. And so I need to say, is C in letter bank? Right? So we'll say if letter bank dot has the letter C in it. So that means I've already seen it. I return false. Right? Now, in this case, remember before all right, so when I get here, do I have an else? I could have an else, but I need to do something else if it's not there. So I'm going to do this 2 ways. So first I'm going to say else, because either if it's already there, I'm done. If it's not there, I need to add it to the letter bank, right? Add this letter to show that I've seen it. So I'm going to say letter bank dot add C. And still, in order to know that I'm done, if I get here, it is an isogram. So I'll return true. I'm not dealing with I still need to deal with upper and lowercase, right? I didn't do that. I'm just doing my first little test, keeping things very simple. So I am going to test my happy like this. And I don't need this part right here. This was just a quick little test. All right, let's see what we get. And where's my window? Over here. And I get false. And let me check something like red. And I get true. So I've got to add my lowercase in there. But I want to talk about one other thing before I do that. Can somebody tell me, do I actually need this else here?
No, you can just return.
Well,
true.
I still need to do this. No, it's not that, but I don't need an else. So this could be coded. How do I want to show you? Because I want to keep that there, sort of. I still need to do this, add it. But the point here is because I'm saying return, if I take that path, then I'm gone. If I don't take that path, I still have something to do. I need to add this, whether you do it with an else or not. In this case, this is, again, programming something sometimes has different ways to do the same thing. In this case, it will work with the else or it will work without the else because of the return. How am I going to deal with the upper and lower case? How about we just change here? We just need to make C dot to lowercase. So we'll just always put in 2 lowercase, or it could be 2 uppercase. Okay, and I think that'll fix that. Let's check and see. HAPPY. And so, yeah, that gives me false. So if I'm checking, does it have the lowercase version of this letter? If it doesn't, then I'm adding the lowercase version to the string. And look, if you want to sort of see what's going on as we're doing this, let's watch what happens. So here, after I add, let's do console.log letter bank is so we can kind of watch what's going on. Right? So first it's an H, then it's an H and an A, then it's an H, an A, and a P. And at that point, then it's gone. All right, so Peter is asking, yeah, so Mike, I'm not sure. Is there an advantage to doing this one way or the other in terms of when to do the check for the?
Yeah, I mean, if you wanted the, this is kind of a case where it probably, like, you want to write the code that's the most clear and as opposed to the efficiency. But if you're thinking about efficiency, you could convert the whole string to lowercase before you do any of this. Yeah, and then there's a one call in JavaScript that'll just convert your entire string to lowercase, so you never have to worry about it. That's like another corollary to what Pam was saying about getting rid of the situation if you as the very first sentence of your first line of your function, you can just say, I'm just going to convert the whole thing to lowercase, and then everything else in the rest of the code, you don't have to worry about it. You know, it's all lowercase.
Yeah, and I'd have to look up on, offhand. Again, I got C++ and Java and this all in my head, and they're all different about how to convert a whole string.
It's the same thing. It's just string dot two lowercase. It's the same function.
All right.
Yeah.
Yeah, and we could test that by
Yeah.
doing something like this. So if I do that, then we shouldn't have to do, let's just double check. We'll see that we change it all to lowercase, right? So yeah, so one thing, so now I don't have to deal with the lowercase, uppercase thing. So that's a good way to deal with that. Just take it out of the equation.
And this is probably a case where it's faster and better documentation, because you see right at the beginning of the function, I'm ignoring case.
Mm-hmm. Yeah. So there you go. There is our solution there. And it's because we're using a set, because sets are able to do this check for us without going through another search, right? Mike, you can probably explain a little bit about why sets
Yeah.
are more efficient.
Yeah, the set data structure is probably also using, you don't know for a fact, but like I think that if it's the most efficient implementation of a set is kind of like a hash table with Boolean values in it, either true or false. So for every key you add to the set, they produce a hash, which does a very fast lookup. And essentially they make sure that the lookup it's not going to have to scan more than a couple of entries in the table to see whether that's there or not. So yeah.
Yeah, so Mike has a section in his kind of data structures crash course talking about hash tables. And the problem that we're doing next week is a problem that we can approach using hash tables. So in next week's coding session, I will talk a little bit about hash tables so that you guys can understand that and how to implement that.
And you don't have to implement a hash table to use them, which is the
Right.
next thing.
Yeah, sorry, not to implement it, but how to use it. Yeah, absolutely. So what do you guys think about this? And also I want to know if any of you have been working on some other problems that you might want to share or that you might want to offer up as some challenges. And then probably have one more thing I might want to talk about before we finish up. Any comments, any questions about this? Anything else? So this is, a relatively simple problem, but again, you take the thing, you break it down into pieces, and even, in an interview situation, even if you start with the least efficient solution. I mean, sometimes, if you're interviewing, you kind of need to talk through your thought process, and your thought process perhaps starts with that. But then you can talk through how you need to change that and make that more efficient. So that's a good part of it.
I have a quick little thing to add to this.
Yeah.
If you actually go to the code wars, you said you could search for the problem in there. If you go through there, it actually adds a whole bunch of more test cases that make you add more to this code. So if you wanted to keep on doing it, that's a good place to go, because it failed me when there were letters in the input, or if the input was none. So I had to make more arguments for solving it that way as well.
Yeah, wait, now I get the none, but you said if there were letters in the input?
No, if there were numbers.
Numbers.
Like if it was an integer instead of a string.
Oh, if the data type was wrong, like, so this is kind of like making your code more robust against invalid inputs, I guess.
Yeah.
So you're saying if you call it with, 1, 2, 3 or something like that, if you call it, you're saying if you pass it a number instead of a string? Yeah. So look, I have to tell you guys, this is where JavaScript, I don't know if I should say makes me a little crazy, but here's the interesting thing about knowing a lot of languages. I'll see if Mike kind of agrees with me on this. First of all, depending on what language you start with, it gives your brain sort of an anchor point and a starting point, and consciously or unconsciously, you compare everything else to that. because that's kind of your context. So I'll tell you guys a quick little funny story. I've told you guys that I learned programming way back in the olden days. It was a language called PL1. And my teachers, this was actually structured programming was becoming a new thing. All right. Mike remembers these days. You remember Fortran. We used to call it Fortrash. And there was a lot of go-to statements that you did in programming. If you guys don't really know what this is, good. I don't want to really tell you what it is, but just know that there was some very bad spaghetti code ways of doing things. And so my teachers literally beat into our heads that go-to statements were the most awful things in the world and should never be used. So I had learned this PL1. I had a summer job the summer afterwards where I actually had to do a little bit of Fortran. And here's the thing, once you know one language, you honestly should have no fear of picking up another one. It's syntax, okay? It's syntax and what are the details of this language. So I was like, okay, fine, I'll figure this out. And I was trying to figure out how to write a loop. And this was back in old style Fortran. And I stared at it and tried, and I literally couldn't figure out how to make this thing work. And I had to go to somebody and I said, look, I'm trying to write this loop. Why can't I figure this out? And he wrote this code for me that had this go-to statement in it. And I felt like, my teacher told me never to do that, you know? So it all depends on where you come from. Now, where I'm getting at is that JavaScript is what's considered a loosely typed language. And this actually drove me so crazy when I first learned. When I saw something in JavaScript that said I could say, let X equals 5, right? And then I could turn around and say, X equals red. This blew my mind because in a language like Java or C++, you cannot do this. You have to determine upfront what the data type of your data is. And so the kind of thing that you're just talking about to make it, yeah, so look, that's probably where I get this little problem here, is because of data types. So yeah, there are some extra things that you'd have to add in there to make sure that what you have or convert it to a string. Maybe the best thing to do would be to take whatever is given to you here. Can I do something like this, Mike?
I think even the two lowercase might. Oh no, it won't. It won't. Yeah, though. Yeah, I think you keep going. Never mind.
How do I, again, I'm trying to get JavaScript in my head. How do I take this thing? Oh, I know how to parse in.
There's always a toString
R.
method on every object in JavaScript. You can say .toString, and it converts it to a string, whatever that representation is for that object.
Yeah, so let's see if this will work now. So that might be the way of solving this.
And that might not handle like the undefined method, the value undefined, that you might have to handle that separately.
Yeah. So, yeah, I get true. 1, 2, 3 is an isogram. So we took whatever was given to, oh, wait, I put it in quotes. I wanted to not put it in quotes. I wanted to do it like this. Yeah, so that works. So,
But it did want only letters though, not numbers.
What should it do on invalid inputs, I guess, is
yeah, so we
false?
have to check for that.
no?
All right. Yeah, yeah. So that's good. Yeah, but that's a good point that you were, who was that was talking that was bringing it up?
Peter.
Yeah, Peter. But and again, to me, that goes in the category of ways I can make this better and more robust. Once I get the basic algorithm working, then we look at ways to make it better and more robust and to deal with bad data. Yeah. So, yeah.
So one of the, to deal with situations where there were numbers involved and even with special characters involved, I use regular expressions just for those situations where it would actually stop the entire evaluation process. There wasn't a try, fix it so it wouldn't be a true or false. It was just like try again. this has this in it.
Cool. So
But
you wrote a
it was a
regular
lot
expression?
more complicated than I thought it would be.
Yeah. I tell you, regular expressions are things that I'm still I can't write them without referencing some syntax, but
Yeah, and they're pretty much right once. Like you can write them, but I can't read them. Like
Right.
they're
Right.
very cryptic.
Right.
Yeah.
yeah. Can you share that? Maybe you can put it in the chat and tell us how you did that.
I just put it
Or
on.
put it in the Slack, put it in the
Yeah,
channel.
I put it on my GitHub, so it's all there.
Okay.
All right, I'll put it there.
Okay. Somebody asked me about one-on-one office hours, and yes, I'm open. I'm willing to do that. I need to kind of get my schedule together. I don't know what time of day. Is this time of day or later good for people generally? So whoever that is that sent me a message, Jasmine, send me a direct message on Slack and we'll work something out. And then I will try to add a couple hours every week. So if anybody wants to just go through some JavaScript concepts or something like that, that would be a good way to do it, you know? But again, the thing that I want you guys to understand is nobody ever knows all of this. People reference things, people have to look things up all the time. And that's why I think what's really important, at least fundamentally to me, is that you can kind of talk through, you know, writing these comments and things like this mean that you can sort of talk through what the approach is. And I think in an interview situation, that's a really important thing, is to be able to help them understand your thought process about what's going on, right? So I hate seeing code that doesn't have comments in it. I'm one of those naggy teachers. If you're in my class and you give me something that works perfectly, but has no comments in it, you're going to lose a point or two, because comments should actually not be an afterthought in my mind. They're part of the process of coming up with a solution to solve the problem. Okay. All right. So I don't know how much time you guys want or how much time you have. We can do a little bit more, or maybe we should kind of wrap this up for today.
Yeah, I think that's good. Hey, Pia, by the way, your GitHub repo is great. It's she has a comprehensive discussion of the problem and how she learned, what she learned from. So excellent job on that. That's very cool.
Really good.
Thank you.
All right. Tell me what.
Oh, did you have the next week's problem?
Yeah.
Do we post that yet, or is that going on to the Slack channel?
It should have gone out, and I'm trying to remember now. I've got to go get it. It's going to go on the site. It's oh my God, I've had so many things going on in my head lately that, where did I put it, Mike? It's in the email. Did you guys get the email? Hold on, let me.
I think it maybe went out an email, but I think it'd be good to post on the coding challenges Slack channel, because that's where I would go to look for it.
I am going to put it there. I was going to put it there after this. And I'm just trying to remember, because here it is. I'm going to tell you guys. No, that's number one. Is this it? All right. And we're going to wrap this up. And I have another problem. I may end up just writing up and maybe making a video about another problem that I want to talk through. Yeah, we're going to do, here we go. Here's what the new problem is going to be. I'm going to put it in Slack, and I am going to put it here as well, if this document will let me grab it. So I'm actually going to go put it in the Slack channel real quick first. Here we go. And I'll put it here in the chat. So
I see it.
yeah. And so this is another problem. This is a problem that we can use to discuss hash maps. So it's got a little bit of similarity, but we'll be able to discuss a way to use hash maps with this problem. And so that'll be a new concept that we can talk about next week. I'm going to try to see if there's a particular concept that we can focus around on each problem. So this one kind of had to do with strings and string manipulation. So we'll do some others. And again, guys, I really would like the Slack channel to, hopefully be something active. If you guys are working on a problem, having a little struggle with it, post about it, let everybody know, other people can try to work on it as well. If there's problems that you've solved that you think are interesting problems that you think other people might want to do. So let's kind of get a little community going on, a little bit of some conversation going on in there to help you guys out. All right. All right. So I don't know if we have any other announcements or anything, Mike, before we wrap up.
No, I don't think so. I had posted a couple of things in the challenges, which are more optional.
Yeah.
They're things that I did for fun as visualizations that you can build in CodePen. So if you have any questions about those, I posted a video about the maze, building a maze, and another one which is kind of practicing sorting algorithms. So
yes, sorting algorithms are important things to kind of understand.
yeah, it's kind of a deep. I mean, the Wikipedia page, I was looking at all the research, all the things about sorting. There's so many different sorting algorithms. It gets really complicated. It's good to know the basics though. So anyway.
Yeah.
But other than that, I don't have anything else. So thank you, Pam. That was really fun. I enjoyed that.
Yeah. And guys, so if you do, a couple people have said in the chat, but I don't know if I've grabbed it all. So if you want to try to schedule a little one-on-one with me, just send me a direct message in Slack and I will make sure and schedule that with you. Okay. All right. So I think with that, we will call it a day and see you guys in the Slack channel and then see you here again, same bat time, same bat channel next week. Okay.
All right.
Thank you.
All right.
Bye, everyone.
Thank you, Pam.
Thank you.
Thank you.
Thank you
Bye,
much.
everybody.
Thank you.